Alright guys, so we're gonna go over um, how to 3D print. So first up we need to go to the Digital Fabrication Lab here. Literally you can just Google like KSU laser cutting. Just scroll down to the link here, and then if you scroll down to fabrication and process and look at these three links here, it essentially runs you through the steps on how to install Cura and the 3D printing farm guide. Essentially, what that is that's the 3D printing farm that that they have set up at the school that's located in the N building, room 315. So I'll take you guys through the steps on how to essentially get your file scaled down and everything from Rhino and then put into Cura, which is the slicer. And we'll go through the steps on how to get that and how it can be read on the 3D printers themselves. So how you could send them to actually get set it up to print. So first things first, we need to open up our Rhino file. So I have just a project that I've been working on for Studio this semester, and we're just going to use that honestly. So we have this volume here, and we have this project that I'm working on. So let's just say I want to 3D print one of these volumes, right? What we're going to do is we're just going to copy it over, and we're going to bring it over to here, right? So it's something that people don't quite understand about 3D printing is that um, printers can't print on thin air. So as an example, right? Say we copy this, we'll just rotate it real quick. So say we try to print it like this, and the print bed is basically starting here below this object, right? This would be a terrible way to print, and the reason why is basically what would happen is the 3D printer itself would start on the bottom layer, and then it would have to print this top portion here, right? And essentially what it would do is it would fill in a bunch of supports on the inside here, all the way up to the top, and then you'd have to take the supports out. Now the good thing is, right, supports you can take out fairly easy. The supports will be generated once we bring it into Cura, the slicer program, and stuff like that. And most of the times, 9 times out of 10, right, you'll have supports in your project. But the idea is to get rid of or try to minimize the amount of supports in your model. So printing an object like this would be terrible. Printing an object like this would be great. The main reason why this would be fantastic is because, believe it or not, for this object, this wouldn't need supports at all. Now, it probably would need supports essentially if we made a hole through this object and had a window or something going through it, right? So for this exercise, we'll just go ahead and we'll just make a hole real quick, so I can kind of show you guys what those supports would potentially look like inside of Cura. So let's do this, and that's grouped, so we'll ungroup it. Then we'll make a hole. And now that we have our hole here, right, now this could be treated as, something that would need supports in, so like a window, right, in our building. Now, instead of printing your building at once, right, it might be smart to print it in multiple sections instead of, like I said, all at once. Now, for this exercise, for Decom 1, you guys all need to print one specific component of your building, which is the outer shell. So you guys don't have to worry about splitting your things up into multiple sections. The idea, though, however, would be to first start off with your original copy of your building, copying it over, and turning layers on and off, basically depending on what you're going to actually use for 3D printing, or what you're going to use to laser cut, or what you're going to use for essentially any of your materials, right? So once again, say that was your original thing that you wanted to completely make, then we would bring it over to here, copy it. Well, this version, we'd copy it, and then you turn off any of the layers you don't want. So for example, like a lot of you guys have furniture, so you would turn off your furniture layer, right? Before copying it, I mean. And essentially what you would do is, um, bring it over here and then start working on the things that needed to be printed and the things that would be laser cut and vice versa. So let's just say we wanted to 3D print this section, but not 3D print the bottom, right? Then we would essentially just move this over. This portion would be 3D printed. Oh, that should be solid on the inside. That should be that. Oh, there it is. Yep, accidentally moved it over. So this portion, right, we could say that this portion would be 3D printed, right? Oh, geez, give me a sec. There we go. So that, yeah, so this portion would be 3D printed, and then this portion we could say would be laser cut essentially, right? And laser cutting we'll go over at a later date. Um, right? So you would split it up kind of like that into multiple chunks, right? So it's almost like you're making a list or a set of parts and an assembly kit to kind of just start pulling out things from your original model. So never actually move them. I would always just copy them just so you know what you've done already. So for this, right, we would copy this over and that'd be like, okay, great. Well, that's going to be, 3D printed. And then you would do the same thing here and we'd say, okay, this is probably going to be laser cut. So you move that over there, and that would be laser cut then. So then you'd prep this one for laser cutting and this one um, for 3D printing, right? So now, say you get all of this stuff ready. Say you get this ready for laser cutting specifically, right? Now the next step would be to highlight each of your components that you would want, including your stuff that you're going to laser cut, and we need to scale it down to size, right? Now this is 1-to-1 scale currently. See, it's in feet. So if we highlight this, this is however big my building is. I think it's like 200 something. It's 300 feet by 220, right? So obviously you can't really print that. So we're going to go to a top view, and then we're going to make a box, and we're going to make it 9 inches by 9 inches, right? It's all the way down there. Really, really, really tiny. So easiest way to find it is just kind of highlight it. And then we could do zoom selected, right? And now we're zoomed into it. So what we want to do next is we want to make sure that these components are scaled down and can fit inside of this red box. Now, I don't mean both of these components, including both of these components. I just want to say make sure that at least the building, right? Because this is the footprint of the building. So if this fits in, then that means this will also. So we're going to highlight this, type in scale. Now, the nice thing for this project is we don't need an actual scale. It can be kind of arbitrary. So we're just going to scale it down. So it asks base point, enter for automatic. We'll just click our base point here. Now, when it asks for a scale factor, basically we're just going to choose the length of the building or just something longer than that. And we'll just slowly drag it down essentially until it gets pretty dang tiny. So we have that. And now we have our plate over here. So now you want to start moving this over using gumball down to here. So look how much smaller that is now next to our base. So same thing, we'll scale it down again. Right, keep scaling it, keep scaling it. And the reason why we're doing 9 by 9 inches is because that's about the size of the bed plates for the 3D printer to handle. Now, on a typical exercise like this, if you were making this for a different studio project or something, you'd probably do an actual scale. So you would highlight this. If it was the original scale, you type in scale, and then you would choose the objects and choose a scale factor to scale from. So, like 1/32 or 1/16, 1/64, anything like that, essentially. So next up, what we're going to do is we're going to move this into here, and because we want to really make the most out of our model, is we're probably going to scale it up a little bit to get it to fit nicely within that 9 by 9, right? So we have this. So it looks like this actually isn't square perfectly. So what we're going to do next is we're actually going to rotate it. So I'm going to move this over, and then I'm going to rotate it. And the reason why you will probably want it to line up is the way the filament works, right? Think of it like just a basic printer. Printers print things from top to bottom, essentially, right? It prints from the start of the page. You see the ink slowly printing out line by line, essentially. That's what 3D printers do. They 3D print line by line. So it would probably be best because it's in a grid that your filament lines all line up top to bottom and left to right, essentially. So just everything's all um, parallel with each other. So now that we have this, and this looks like a decent size in here, the next thing we're actually going to have to do is change this, right? Now, we need to change our units, so we're going to right click on feet. We'll go to unit settings, And now we need to actually change this from feet to millimeters. And the reason why is Cura, the slicer, will actually recognize, only recognizes your model in millimeters for some stupid reason. It's going to ask you to scale the model. We're going to click yes, just give it a second. And unfortunately it disappears sometimes, so we're going to have to zoom it out. And there it is. An easier way to do that so it doesn't disappear on you like that is to keep your object selected after you click the scale button, or prior to clicking the scale button. That way, if your objects are still selected, then if you click zoom selected, it'll go right to it. So here it is in millimeters. So we're going to move this over here. And this is the portion we want to laser cut. We're gonna not worry about this, but the good part is, since we want to make that for laser cutting, this and this is the same scale now, which means that once we start assembling the laser cut portion of our model, it will be the same size as the 3D printed portion of our model. So make sure when you scale objects down, right, for your model when you're assembling and making it, that it's all the same size, right? You don't want to scale one object down first that you're going to 3D print and then later on scale the part that you're going to laser cut, because that would probably mess you up, honestly. So next up, what we're going to do, right, is we're going to export this into something that Cura, the slicer that we'll get into in a bit, will recognize. So we're going to highlight this, not the line, because that was just used for a template for us more than anything, so we don't have to worry about it. We're going to type in export. Now, it's going to ask you to export stuff down here, Rhino 7, 3D model, 3DM. We don't want that. We want this file called an STL file. That's basically what Cura recognizes. I'm going to just save it to the desktop, and we're probably going to call it, we'll just call it test or something. 3D print test. So we're going to save that, and then we'll click save. Now it's going to ask us here, it says the maximum distance between the original surface or solid and the polygon mesh created. Typically I just leave this more than anything. Essentially that just means the amount of tolerance and things like that. We're just going to go ahead and we're going to click OK. Access here between binary and ASCII. I don't know what the difference is. Typically binary is fine. Leave this as just whatever the typical is, and then we'll click OK. Saves really, really quick. It says file successfully saved as, and then it shows where it's saved. So what we're going to do next is we're going to go get the object. So I'm going to highlight this, Control C, and I'm going to open up File Explorer here, paste it into the command bar, and then, that's fine to show the desktop, and then see, there it is. And the cool thing is it's actually already recognizing it as something by Cura. So when I copy it into the command bar, believe it or not, it's going to open it up in Cura. And here it is right here, which is awesome. Now, for those of you guys that don't have these files actually recognizing by Cura automatically, I'll essentially show you guys what that'll look like. So say you have, Cura just open. You'd go to open it first. Then the next thing you would do is we'd go to our File Explorer here, and then we can just drag and drop it like so. And there we go. And if we compare it to our Rhino file, right, we'll go ahead and look at it from a top-down view. It is the same exact size as the one from Cura, which is great, which means it's scaled properly. Another way to tell is if you click on the object and go over to here where it says scale, as long as it says 100%, then that means your object hasn't changed whatsoever. Sometimes Cura will actually change the size of the object, and you need to be really, really careful of that, because once again, if this is scaled to a different size than what you're laser cutting, then your whole model is going to be screwed up, and you kind of don't want to, have that happen, essentially. So next up, right, we're going to go to our basic settings. Now, this is the part where if you don't have Cura currently installed yet and you didn't follow those instructions that I showed at the beginning of this video, you're probably going to want to go ahead and pause and do that, because these settings and stuff won't actually appear for you, and these presets won't appear for you until you do that on their website. So make sure you get that done first. So what we're going to do next, right, assuming that you have that done, is we're going to click on this one right here, which is Creality CR20. These two you probably won't see. Those are my personal printers, but you'll see either this one or the Ultimaker S3. Typically, we can leave it on the Crealities because that's the most amount of printers the school has. I think they have like 10. They have a decent amount of them, so that's the one we'll leave it on. Next, we'll go over to here, right? You don't need to look at any of that stuff because that's all your detailed stuff. Typically, we can look at just the default. So if we go to, actually, no, we do need to look at that, my bad. So if we click this over here, these are our presets, and then we go to custom, and then see where it says profile. If we click on this, there are 3 different profiles that the school actually has set up. It has one called standard quality, high quality, and low quality. Now they've already changed all of these presets in here if we scroll through all this stuff, and you guys aren't typically going to want to have to change these at all, unless you have a massive print like this. Okay, you might want to change stuff like this, and I'll explain a little bit of that to you guys to help you guys out in the future. So um, we're going to go ahead and click standard quality, right, which is just their preset. We're not going to change anything, and we're going to go ahead and click slice and see how long it'll take. So the slicer currently says that this will take 19 hours and 32 minutes to print, and it'll tell you how many grams of filament that it'll take up. Once we save this, right, it'll export as a G code, and then we can upload that to the website, to the 3D warehouse website that we'll get into in a bit. Now, before we do that, we can start tweaking with these settings depending on what we're fine with and what we're not fine with, right? So the first thing we're going to do is we're going to go to preview at the top here. Now, what preview does is it'll actually show you exactly where different things are going to be. So it color codes it. I forgot what the color code is off the top of my head. I know the blue here represents the portion that the printer starts out with. So this surrounding is called a skirt. And if we scroll down here onto the side, I think it's below support. Where is it? Build plate adhesion type skirt. Now, typically for a smaller object with a smaller floor plate, right? Say it's a very small object and then it gets bigger as it goes up, like a cone or something, then you'd probably want to do a brim or a raft. Now, if we click brim and we'll click slice, watch what happens. The brim actually makes a border around the shape, like it's holding it in place, and it locks it in place. And the yellow represents the bottom of our object itself. So the blue portion goes right up to the edge of our object. Now let's change it again. We'll change it to raft this time, and we'll slice that. So if we go over to raft, now raft obviously takes a lot longer, 21 hours. And the reason why is because if we look underneath, look at that. See, hence the name raft. It literally prints a massive raft or a massive portion of filament, a couple of layers for the object to sit on. Now, a raft would be beneficial if you're having trouble with your print sticking to the bed. Now, you guys won't directly have those issues because the people there in the workshop, they'll be manning the 3D printers. But to save you some time from failed prints, one of the things you can do, right, is increase your bed adhesion by changing this to a raft or a brim. Keep in mind, again, that the only time you would really have to use one of these things is if you have an object that is very, very small, surface area wise at the bottom, and gets bigger up towards the top, essentially. So that's kind of the only time you need it. So as an example, real quick, let's go back to Rhino. Right, we'll just make a cone, and essentially, so we have very, very tiny, tall, really, really wide, right? If you made an object like this on the 3D printer, you would definitely want a raft or a brim at the bottom, right, to hold it in place. Because imagine the 3D printer trying to print all of this, right? Now, depending on how steep this is, it might actually make supports here, but if we made another one, it might not actually make supports if it's a little bit lighter like that, right? Now, you just got to be aware of stuff like that as far as like what you think the printer will probably make supports on it. It'll probably definitely make supports on this, but it probably won't with a grade this, not as steep like that. So we'll go back into Cura. So that's essentially how skirts, brims, and rafts work. So for you guys though, you'll probably only have to use either a skirt or a brim. For this object right here, we're going to use a skirt because it has a massive amount of floor space. So we don't have to worry about that at all. The next part that we'll look at is the supports that I was talking about earlier. See that hole we made inside of our object? All of that is going to be supports. So see these tiny X's right here? Basically, this will, the 3D printer recognizes, right? And it realizes that it actually has to build supports because it can't, just print on thin air. So we're actually going to go over to here, this column, this number 34034. That's the amount of layers it'll go through. So if we just drag this down, you can actually see what each layer essentially looks like. So here's what the very first layer would look like when the 3D printer, the nozzle starts moving. And here's what it starts looking like later on. And you can actually see the inside. This is called the infill. Now you can actually turn this down, believe it or not, depending on your object. Typically it's good to change the infill for a bigger object like this. Honestly, for an object this big, I definitely don't need this dense of an infill. So we're going to scroll up to infill right here and infill density. The only thing you need to change if you wanted to would be infill density. So we'll change this down to 5%, and now we'll click slice, and let's take a look at what happens to the infill on the inside. Well, look at that. The pattern's way, way bigger. And see how it takes a slightly shorter period of time? That's fantastic. So essentially, if I were to actually open this up, it would be these hollow hexagons right here. And you can actually change the pattern too. But I won't worry about any of this stuff, really, honestly, for this right now until a little bit later on, once you guys start 3D printing a little bit more. So we'll scrub this up a little bit to take a look. Look at that. Now we're getting to the overhang for this opening or window, whatever it is, essentially. And that is made out of these supports, right? It's made out of the same exact material, but the nice thing is it makes these X's at the bottom, and if we scrub all the way up, it makes these at the top too. Essentially, it just makes it really, really easy for you to get rid of these supports. Now, now they also have printers that have soluble material. And essentially what that does is, like, say you have something with a crap ton of holes in it and it's just way too much supports, but you need to get it printed. So typically what you could do is you could actually change this on the printer if we go back to prepare. And I don't have the preset for it. I think it was back when the school wasn't doing this, but essentially there would be a preset for a printer and a new standard that allows you to have soluble, essentially. And you would just switch it to that if you would have more supports. Um, Once again, though, for this project, you guys aren't going to need that at all, so don't really worry about that right now. Anyway, so um, for this exercise, right, we'll do standard quality. We made sure it was a skirt, and we'll go to preview, right? You can click preview here or up here, so wherever, it doesn't really matter. And once you're happy with it, then what we'll do is we'll click save to disk, and then we'll save it as whatever we want to call it. So it says the printer name first, and then the name of your object, which is what we call 3D print test. So we'll just go ahead and save this to the desktop. Looks like it's saved. We'll open the folder that it's at. It's right here. There it is. So now we'll go back to Google, and we'll go to 3D, not 3D Warehouse, 3D, there it is, 3D Printer OS. So the school stuff. So essentially, these are previous projects that I've done. I haven't really deleted them. They're just still here. Um, you know, and there's also these ducks, right? They also have that stuff. Those just stay there. Essentially, what we want to go to is add files. It'll ask to drag and drop to upload content. So let's click our folder. There's the object. We'll drag it here, and then it'll upload. So essentially, we can wait for it to upload. And it'll ask us to select the printer type here. So Creality Ender 3. Let's see, where we sliced it in, let's go back to prepare to take a look. It was in the Creality CR20. Typically stuff like that doesn't matter as much, but let's see, that's the CR10 series. The Creality Ender 3s are the CR20s, I'm pretty sure. So then you can click save, and then it'll load, blah, blah, blah. And then once you're ready, then you can click preview. And the cool thing is this preview actually comes up and it looks similar to the area in Cura, right? The interesting is you can actually upload STLs in here and slice them in this software. Although I know at the school they were telling us not to do that. So make sure you're slicing in Cura. So make sure you're getting that G code file from Cura specifically before uploading it to Printer OS. All right. But essentially, you could open this up, just preview it, make sure everything's okay, and it looks like they have the color legend here. So infill, that's the stuff in the middle, right? So if we, move that down, there we go. Now we can see it. Inner wall, there's the interior. Service parts, that would be the support, right? That's what the support essentially looks like. So comes up better here actually in this software. Um, let's see, unknown, that is interesting. So when artifacts like that comes up, typically they won't print, so we're not going to worry about that. Shell exterior, and that's about all you would need. So we're going to click the X button now that we previewed it and we made sure that it fits and it's inside of the bed, and it'll show you how much it costs here. That's how much I have left, and it shows you the preview of how much it'll cost. Then what we can go is we can click the print option. Now the first thing that'll come up, right, will be all the printers that the school has available. It looks like every single one is being used, and these two are paused actually right now. But there would typically be some that would be green, right? It would be a green icon, and green means open, right? So you would want to either click on the one that's open and has the amount of filament or enough filament, um, for your project, or you would just queue up behind one that would take that's almost done. So essentially what you'd want to look up at here is how much filament your object takes. My object is 197.29 grams of PLA material. So we need to scroll through and make sure that the printer we queue up behind, right? So essentially, this one we couldn't use because this one's 990 grams of filament left. This is 90% done. So even though this one's pretty close to being finished, if we were to queue up behind it, there wouldn't be enough filament left. So typically you'd want to queue up behind a printer that has enough filament left. So, oh, for some reason I was thinking our number was 1,000. Now this is plenty. So I don't know what I was thinking. Sorry. Oh, here's a better example. Yeah, these. So, and it actually shows you as well in red, which is good. So um, that's good. So obviously, so like this, paused 0%. Obviously, this project was paused because, there's barely any filament left. So that makes sense. And probably the same thing here. And this one is still printing, actually. It's not even 1% done, and it's running pretty dang low. So, it's stuff like that you need to be aware of, right? These printers are offline. Looks like they don't have them ready. But essentially, once you're ready, we would go and click our printer. Let's see. So this one, right? This one's 90% done. So we definitely want to queue up behind this one. So we click this. We want one copy. We don't want to make multiple copies. And then you would click the queue button. I'm not going to queue this because I don't want to print it, but you click queue. Then you get a notification on your phone that your object has been queued and sent. And then you'll get a notification later if it starts printing. Now, you'll also get notifications sent in case, the people working there tell you that there's issues, or if your print's been canceled, or if they've transferred it to another printer. So you can do that as well. But that's essentially what you would want to do for the printing portion for the farm that we have set up. So after that, then you would want to that you want to get it printed, and I think that covers it. So yeah, I'm pretty sure that's about it. So yeah, all right. Hope this helped. See you guys.